And before we go into the panel today, we have the last presentation that is coming from Copprint, which is offering a very unique solution of screen printable copper paste. We have Ofer Shochet, who is CEO and co-founder of Copprint. He has a very long title, but Ofer, I will let you lead you through the presentation.
Perfect. Thank you so much for inviting me to present. Let me see that I can share my screen. Just a second. I hope you can see it well.
Yeah.
Perfect. So, well, it's not easy to be the last person on the list, but now I'll try to move quickly and talk about conductive copper paste in the world of PV metallization. I will start by talking first about Copprint, who we are. We are fully focused on, we are a material company, a chemical company. We provide ink, just the ink that you see here on the right-hand side. It looks like chocolate, just more shiny. And we are providing low-cost conductive paste and sustainable solution. Our key markets are actually in the world of PCB. We are active in photovoltaics only recently, but we started with world of circuit boards, antennas, and we are replacing with our copper ink either silver inks that are 3 to 10 times more expensive, or we are replacing etching processes that are expensive and also very polluting. Copprint is a small company out of Israel, but we are supported by top investors, strategic investors like Henkel, HP, and Tatsuta, which is a public Japanese company. And we are well known, I believe, today as a clean tech company that enable people to manufacture in a more sustainable way. So before I move into the world of PV, just to give you some glimpse on other products and activities for our customer, you can see different circuit boards printing on the left bottom side. You can see printing on glass to make transparent display. This is from a customer in China. On the top left side, you can see street lamps that are printed using our ink with copper on aluminum, and then LEDs are etched. Capability to do roll-to-roll processing, soldering, many parts. But let's move to the world of photovoltaics, because I believe this is a lot more interesting for this application for today. So in the summer, there was an article published by Bloomberg, which the title of it was the world appetite for solar panels is squeezing silver supply. And there are a few graphs that are very interesting there to show first the demand of silver versus supply in the last years. This is on the left side. You can see that the average supply in the last 10 years was about 33,000 tons of silver per year. And in the middle graph, you can see the demand coming from the solar industry for silver. And if 10 years ago, this demand was very minimal, we've been growing, and right now at 2023, we are in the order of about 5,000 tons of silver demand from the PV industry. So we are becoming more, we impact more the PV market, because photovoltaic silver is now becoming larger and larger. And 2023, this is still before the transition to the new technologies. We are still working mainly today with the PERC cell, and we are just transitioning to TOPCon, HJT. And on the right-hand side, and these are all graphs from Bloomberg, you can see the average consumption for PERC, it is around 10 milligram per watt, while for HJT, it is more than 20 milligram per watt. And of course, the trend to go to a higher efficiency cell exists, and therefore the demand for silver is increasing. So everybody in the industry is trying to reduce silver consumption. We heard about it. We will hear more. There are a lot of alternatives to do that, to make thinner lines, bus bar-less designs. And I took here a graph from ITRPV that shows the trend of, how they see the next 10 years in terms of silver consumption per technology, and the fact that it will go down and down over time. So on one hand, this is good because we will use less silver. At the same time, the trend is to move to cells with higher efficiency, so more silver usage. The market itself is growing. So what I've done recently and this week, and many thanks to my friends at ISC Constant, to Rado and to Joris, that helped me with that. The market itself is growing. There is a transition to the different technologies of TOPCon and HJT and IBC. And there is a trend to reduce silver. But if you combine all the information together, you get the graph here on the right-hand side, which has a copper background, of course, which shows that if we are at 2023 at around 5,000 tons of silver, then if we continue with whatever the market is predicting now, cutting silver, growing the gigawatt, transitioning the technology, by 2030, we will get to something like 27.5 thousand tons of PV, which is, if you compare, I brought in the same graphs that I showed earlier for you to see the silver demand and the PV and the history of PV demand. You can actually see that by 2030, the photovoltaic industry will need all the PV that can be supplied. Okay, so that's a bit of a problem because we cannot, double our world silver production very easily. And the conclusion is that silver price will surge because of that. But there are also good news here. You can see pictures from ISC Constance. You can see these were the first Zebra modules created. Very high efficiency. We all heard the presentation of Rado about an hour and a half ago. And these cells have actually less than 4 milligram. They all use screen printing, no other wet processes or plating. And, high efficiency, manufacturing ready. It means that we passed all tests. I will elaborate later. And as you heard from Radovan, Futura-san is planning to adopt this technology starting as of next year. So let's understand more about copper. So first to say, copper is a great alternative. We all are aware of the volatility of silver, sorry. I eliminated here the peak from 2012 of $1,200. This was a scary period of time. And in the last 4 years, we are on the average of about $800 per kg. Okay, but as a raw material, copper is dramatically better. It has lower cost. It has about the same conductivity. The carbon footprint is dramatically better, more than a factor of 40 better. And toxicity in terms of what will happen to the copper or silver when it goes to water sources, to lakes, and of course abundance. With silver, it's not infinite. With copper, there is at least 1,000 more copper in the world than silver. And there are also additional technical values. For example, copper is solderable with an intermetallic compound, and there is no silver migration, which enables to keep the right line widths and distances. So you heard from Rado, the process with them includes a little bit of silver as a barrier layer, and then the copper is on top of it. In terms of performance, the performance of copper and silver are the same. This is all published since already more than a year ago. And we've done a lot of work together. Probably I should say ISC are doing a lot of work, and we are supporting them as hard as we can. And of course, because this is the first version with copper, screen printed copper, a lot of tests are done. For example, 3,500 hours, 85. We want to be sure that everything works well. And then testing from the beginning, you know, the throughput, the series resistance, the solderability, the adhesion, and we are all passed. So now it is approved, and hopefully next year going to larger scale production. Of course, as you heard from Rado earlier, you know, we continue the work to move into polyzebra, higher efficiency, and even lower silver consumption as part of that. And this is really great. So what's unique about Copprint? We can overcome the oxidation of copper particles. And the copper particles, I mean, if you work with copper, it becomes green on the outside when exposed to oxygen. So the green, the copper oxide, is the electric. So when copper particles touch each other, there is a green barrier and there is no conductivity. And many people try to develop it for different markets. At Copprint, we have a great solution. It's based on a granted patent in Europe, in China, in Japan, in many other territories. And it is based on a process at low temperature, under air, with very simple equipment. We will go to that in a second, and all can run in extremely high speeds, as you will see. So the process is fast, high throughput, and very low capex. How is it working? Very simple. You start with printing, use your standard screen printer for that, and then we perform a very short drying. In the lab, it will be using a lab oven. In a production line, it can run at extremely high speed using any drying solution of, you know, few seconds drying can work. And then there is an additional process, and I put your attention to what's happening on the right-hand side. Here, this is how it is done in the lab. This is a very simple office laminator that you can buy for about $300 in Amazon. We took, in this case, the solar cell. There is a protecting layer, making sure it will not be scratched. The way this laminator is built, it's actually contactless. You can see it on the bottom. It's two hot plates and the substrate goes in between. And when it comes out on the other side, in this case, the dwell time is 12 seconds only. It is highly conductive. So what do I mean highly conductive? It means that you can get you get to the order of 5 to the 10 to the minus 6 ohm centimeter, with this, what we call it, snap heating. It's a very quick heating process. The temperature must rise up very quickly, and then the rest of the process is few seconds. The protecting paper is preventing for extra oxygen to come in and from scratches. This is how you will do it in the lab. And if you want to do it in larger scale, this is out of our first run for an off-the-shelf equipment. This is actually like a big laminator. It's called double bed press. You can see here Dominic from ISC. He's not fast enough to meet the machine, and you can put a lot more cell on the right and left. So probably we will not hire him for this job. He can do many other things much better. And as it goes to as it comes out on the other side, this is a machine coming from Germany from a supplier called Mayer. You can see actually Andy, Ning Chan, still in this time at ISC, picking it up, and again, great throughput, very low capex, I would say, for such a high throughput. When you do sintering of cells, the first thing people ask me about the temperature, because we are usually processing it for a few seconds, temperature between 250 to 300 C. For example, for HJT, there was a recent work, still not completely published, but they let us publish it, from Jülich. to show that this very quick heating is not impacting performance. Actually, it even improved the performance of HJT cell. The other question people ask us is about line printing widths. We are still working on it, I can say. We just released a few weeks ago a new paste called LF365, which has the conductivity of 5 microohm centimeter and have spreading which is less than 10 micron. So this is something we already achieved and shipped for customer for testing with very good feedback so far. So one thing that people ask me to save it from the chat room, what is the price? We are selling a kilogram for $700, 500 kilogram, the price will be about $400 per kg. And for larger amount, it will also even be cheaper. We can commit on pricing for more than 2 years, unlike silver that is very, very volatile. And probably I want to finish my presentation calling you to partner with us to cut your silver cost. You need to imagine that because the demand is going to grow so much, you need to start thinking about silver price, which are not $800 per kg, but are $1,200 per kg. And now you need to also to imagine $1,500 per kg and how it will impact your cost, how it will impact your competitiveness and your market share. And maybe I will say as a almost joke or not, if you want to invest nice, either buy a lot of tons of silver because silver price is going to increase dramatically, or you can just invest in Copprint. Thank you so much. Maybe last very quick slide. We are working as part of IBC4EU. Radovan talked about it earlier, so I will not add more information about it. Thank you so much.
Okay, thanks a lot, Ofer. That's it.